Okay, just to remind everybody, this is just one part of a presentation that I gave this summer at the Cosmic Summit. If you want to see the presentation in whole, please go to the Cosmic Summit's YouTube page. They have all of their presentations uploaded there, and you can see all of them. And each and every one of them is fantastic. My presentation on Carolina Bays was just one of many. And you know, personally, in my opinion, mine was probably the worst of all of them. But you know, head over there to the Cosmic Summit's YouTube page, and if you want to see this presentation in full, you can find it there. Now, up to this point, we have pretty much determined that, you know, based on statistics and probability, it is a very low chance that these Carolina Bays could have been formed by natural wind and water processes. We have also determined that it does seem very probable that these Carolina Bays, these elliptical shaped depressions that all have raised ending rims and orientation leading to the Great Lakes region, are likely the results of something that happened over the Great Lakes region at some time in the past. And these things are secondary to that primary impact into an ice sheet. Now, probability number one that we have already covered was Antonio Zamora's Younger Dryas impact hypothesis, where he feels like an impact happened at the Younger Dryas into the area over the Great Lakes region, and it was giant chunks of ice that were lofted from that impact up into orbit, you know, suborbit, and came crashing back down along the coastal plain and that whole arc up through Nebraska, which created the Carolina Bays and the Nebraska rainwater basins. While that is a very popular hypothesis, it's not the only one. There are other ideas out there, and one in particular I want to cover because I think this one might have a lot of weight to it, and I want to make sure that you all are aware of it as well. Again, I mentioned before that it's not a popularity contest. We've got to look at the facts and the evidence when it comes to these mysteries and trying to solve them. So probability number two comes from a team of researchers, and one we've discussed in the past already, which is Michael Davias. He's the one who has created the Carolina Bay survey, which he just updated and actually renamed the Ovoid Basin survey to include not just Carolina Bays, but also the rainwater basins and the high terrace playas and all of those ovoid shapes that we find across the United States. And in fact, his latest update includes LiDAR from the Atlantic Ocean all the way to the Pacific Ocean. So all of you should go check that out for sure. And the other researcher is Thomas Harris, who I'll discuss a little bit more here in just a minute, because there's kind of something important about a discussion he and I had. But regardless, their hypothesis is actually very different from Antonio Zamora's. When it comes to timing, Michael Davias and Tim think that this thing had to have happened a long time ago, and is specifically related to a Mid-Pliestocene transition event. That is an event that happened 786,000 years ago, which is a whole lot older than 13,000 years ago. Now, one similarity that this hypothesis has to Antonio Zamora's is that there was an impact into an ice sheet. Again, this was just a lot longer ago, and the effects were different in their hypothesis. Instead of it being a large chunks of ice that were ejected from the impact site, which they believe is Saginaw Bay specifically, but instead of it being large chunks, this would have been more of a regolith blanket of pulverized ice and water and sand, pulverized Michigan sandstone, that kind of washed over the ejecta area instead of being launched and crashing back down. So that's kind of a big difference. And they call it a cavitated ejecta regolith blanket. Again, that's a big difference. Now, one of the reasons why I think this hypothesis actually holds a lot of weight, first of all, it is the timing. You know, the Mid-Pleistocene transition, there is something major happened during that time. I mean, really major. we actually see a shift in obliquity of the Earth's molecular cycles, where we literally extended our ice ages from 41,000 years to like time spans of 100,000 years. And again, that was 7 or 8 ice ages ago, but there was a sudden change then that extended our ice ages into, you know, hundreds of thousands of years instead of tens of thousands of years. big deal. There was also a geomagnetic pole reversal at that time. Could it have been an impact that caused that magnetic pole to flip? You know, again, just added to the list of mysteries, but that did happen at that time. And there was a major extinction event that happened at the Mid-Pleistocene transition. We don't quite have a lot of data on mega mammals like we do at the Younger Dryas, but keep in mind the Younger Dryas was much more recent. But we find like a tremendous amount of benthic foraminiferous species that went extinct, entire species that went extinct at that time of the Mid-Pleistocene transition. So these are microscopic, you know, bottom dwellers that went extinct. For something for that to happen, major event at the Mid-Pleistocene transition. Now, probably the most interesting line of evidence that they use for linking the Carolina Bays to an impact at the Mid-Pleistocene transition are the existence of the AA tektites. Those are the Australia and Asian tektites that are all the way on the other side of the planet. That's a pretty unique stretch. But this is where it gets interesting. Tim Harris, a few years back, was down in my area of the woods. He was traveling down with his son. It was actually during COVID. And he contacted George Howard to see if there was anybody in that area, the Savannah area, and I'm just a little bit south of Savannah, to see if anybody in that area wanted to talk about Carolina Bays, because he was going to be there, and he was just looking for somebody to talk to. And he gave him my number, and of course, when he called, I said, hey, man, just come on. You can stay at the house. My sister was actually in town with her nephews, but I said, you know, come on, we'll find a place for you. And you know, we actually had a really great evening. We had some really serious discussions about Carolina Bays. I wanted to know more about their Mid-Pleistocene transition event. At the time, I was like totally on board with Antonio Zamora's hypothesis. But come to find out, and I didn't realize this, but Tim is retired from being an engineer at Boeing and Lockheed Martin, where he worked on ballistic, like nuclear ballistic reentry from missiles back in the day, and he's a legit rocket scientist, and he has used those same equations for the ballistic missile reentry, launch and reentry, on an impact into Saginaw Bay, and can track the AA tektites all the way back to that location. Not only that, but the AA tektites have a very unique chemical signature which matches the Michigan sandstone. So there is a very strong chance that, yes, indeed, the AA tektites actually originated in Michigan, specifically the Saginaw Bay area. That was pretty interesting for me to learn, and it should be pretty interesting for you to learn as well. So anyways, that's probability number 2. You know, Michael Davias and Tim Harris, their hypothesis is that there was an impact into Saginaw Bay. The sandstone was pulverized. A good bit of it was launched into orbit and came back down as AA tektites on the other side of the world. A regolith blanket washed over North America, and it was actually bubbles that created the elliptical depressions that we see all around the East Coast, and in Nebraska. Kind of like paint bubbles, you know, if you're painting and you get a little bubble and it pops and it leaves you with a elliptical shape. So we have 2 very unique, very distinct probabilities that could be a possible cause for the Carolina Bays and the Nebraska rainwater basins and all the rest of them. We're going to look at this a little bit more in detail, maybe do a little bit more comparison, and try to see if we can come up with you know, at least something to progress this a little bit further. I'm going to tell you right now, I do not know the answer. I'm just presenting you guys with the probabilities, and we'll take it from there. So thanks for watching, guys, and we'll catch you next time. Bye.